Question number 16, part A, define the following terms as used in waves. So the first one is amplitude. The second one is the wavelength. So we start with the amplitude. Maybe we can have a sketch here to demonstrate that. So this is a wave. That's a wave. We start from there. So continues like that. So the displacement from the horizontal mean, or the line representing the half of the wave, is what we call the amplitude. So in terms of words, we can say amplitude is the maximum displacement from the mean position. Position. So that is how you answer part B, part A, Roman number 1. Then we have the wavelength. So the wavelength can be defined in several ways. We can say the wavelength is the distance between two successive points in a wave. So if we take this as a position, this is the other successive part. Will be this one. So this is the wavelength. That's a wavelength from there to there, and we use that that symbol to represent the wavelength. We can also say it is a distance between two successive troughs or crests. So this is what we call the trough. The crest, and this is a trough. So successive troughs are those two successive. Those are crests. These are successive troughs. So you can see it means the same. We can also say it is a distance traveled during one period in a transverse wave. So this is one period. That's one period. That distance is the same as a wavelength. So you can describe it in any of those words. So let me put it like this. This is I would say wavelength. I think the best one is this. Is the distance between two successive troughs or crests, which we have described in a transverse wave. Transverse wave is where the movement is the same, is in the same, that is perpendicular to the direction of the wave, and we can say it's also between two successive liquefactions or compressions in a longitudinal wave. So we have two types of waves. We have the transverse and we have the longitudinal waves, which you have covered in the topic waves. Question number 16b, figure 8 shows water waves approaching a straight reflector at the speed of 40 centimeters per second. So we have the reflector is there, we have the source. This is the source of the waves, and it is 15 centimeter. So draw on the diagram the reflected waves. So we can do that on this diagram. So the reflected waves will be the reverse of these ones. So we have something like that. So these are the reflected waves. Part B, given that the distance between the source and the reflector is 15 centimeter, determine the wavelength of the wave. So wavelength, I can say wavelength is equals to distance divide by number of waves. So this means that you can see here we have 4 waves. So this is 1, 2, 3, and 4. So this is equals to the distance is 15 divided by 4, and this will give you 3.75. That is the wavelength, and the symbol for wavelength is that. Finally, we are required to get the frequency. So frequency is equals to we have velocity, that is velocity over the wavelength. So our velocity we have been given here, it is 40 centimeters per second. You divide by the wavelength which we have calculated in part 1. We got 3.75, and when you divide that, you can use your calculator, you will be able to get 10.67 hertz. The unit for measuring the frequency is hertz. So that is how you answer that question from waves. Part C, question number 16. Figure 9 shows a light rays from two coherent sources, S1 and S2, falling on a screen. Dark and bright fringes are observed between A and B. So we have our diagram. This is A and B. These are the sources of light rays, S1 and S2. So Roma number 1, state how that is 1, bright fringes are formed. So bright fringes are formed due to constructive interferences. This is so we say this is due to, we can say, constructive interference. Dark fringes are formed due to destructive interference. Then number 2, state what is observed when light of lighter frequencies is used. What is observed is that the fringes get closer. So we can say when the frequency is higher, the wavelength reduces. Hence fringe separation decreases. Hence fringe, not fringe, that is fringe separation decreases. Decreases. So this is, so the fringes get closer. So that is how you answer that question.